Welcome to the Pythagorean Theorem Facial Recognition app. Here we have 40 faces from 40 different people. The app holds 10 poses for each one of these faces. So if I click on this face, I'll get 10 poses of this person's face. Now if I click on one of these faces, well, we have 40 faces, each with 10 poses. We have 400 different images in here. So what the app is going to do, it's going to go through all 400 of those images and find the 10 that are closest, not including the face I clicked on. So, and then they're in this order. This is the closest, next closest, and so forth. This is the furthest away. Now, it's not always perfect. It doesn't always match correctly. And so the ones in green are the correct matches. This red one is a wrong match. Now what I want to do is do some kind of a comparison. This is the screen, this is the image I just clicked on, but the computer looks at everything in much lower resolution. The resolution here is there's 23 pixels, enlarged pixels, but they're still pixels in this direction, 28 pixels in this direction, for a total of 644. Now if I want to go ahead and do some investigation and try to see which pixels are furthest away from corresponding pixels, I can go like this, go into this investigate button. Now this is the 644th pixel. I can compare those. For each image, the 644th pixel is right here. That's 644. The value over here is 36. That's how the computer represents that color gray. Over here is 32. So these are quite close. And we get the squared difference. That turns out to be 16. Okay, now this is how we find out the difference between two images. If I go over here, this whoops, doesn't work on that side, it works on this side. So I click over here and I get, this is pixel 590 for each one of these corresponding pixels. This value here is 104. This one over here is 110. Again, we've got this square difference, it's 36. That's what we've got here. If we go to this one here, it's going to be a lot different. Okay, so here we've got, this is pixel 591. The value for the pixel as far as the computer is concerned, that's 80. That's how it represents that color gray. Over here we got 112. That's how the computer represents that color gray. But notice the difference here is pretty big. So what happens here is it gets all of these square differences and sums them all up. So we've got pixel number 1 for each one through pixel number 644, sums all of these up, and that's where we get this value here. Then you take the square root of that, and that's what's considered to be the distance between these two pictures, or how much difference there really is between these two pictures. Now, that's actually using the distance between 2 points formula, which is based on the Pythagorean theorem. So the distance between 2 points formula, if you're in two-dimensional space with 2D, you've got 2 coordinates in each point, and you just take the difference in the x coordinates and you square it, the difference in the y coordinates and you square it. Now if you go one more, 3 dimensions, okay, you've got an x, y, and z coordinate, you get the difference between each one of those coordinates, you square them, you add them together. And now suppose there was such thing as 4 dimensions, well, you would have this kind of a formula. Now what we have here is, believe it or not, we have 644 dimensions. And each one of the dimensions is represented by 1 pixel. So we're using this exact same formula, except we've got 644 coordinates. We add them all up, and we get the square root, and that's where this number comes from. Okay, over here we've got a scroll button. This is just kind of instructive. Students could click on this and kind of get a feel for what's really going on. It will eventually go through every single pixel. You can stop it anywhere and look at the particular values. But it will go through the whole, both images in total. If you sit there for, it's like one every 30, it does one every half a second. So it might take 5 minutes to go through the whole thing, maybe a little bit less. But it's basically a way to look through, just to get a feel for what's going on. Then there's the investigate button that we already used to look at pixel by pixel. Then we did look at the tutor a little bit. Now this is a little tutorial that explains what's going on to refresh a student's to sort of refresh of what's going on, how this thing works. Now, if we go back to the beginning, now we've got these 40 images. These images are from the AT&T laboratories at Cambridge. We can use them as long as we reference them. Now, this is really a prototype app. These are not the images that would be with the real app. The real app would allow the students to actually put in their own faces. They would have 10 poses for each one of their faces, and then they could go ahead and they could compare what their face is in relation to any one of their classmates if they want to. They could also have a little fun. They could make faces and try to see if they can fool the algorithm. Or they could try to make their face look like one of their friends' faces by doing different things with their face, maybe even putting makeup on and so forth. So this would be basically a lot of fun, a way to be an application of the Pythagorean theorem, and it's actually based on research that was done in the 90s for facial recognition. So it's actually based on some research that was ongoing 20 years ago, but it's not like it's 1,000 years ago. It's kind of recent research. So it's kind of a neat way to do the Pythagorean theorem and introduce the concepts of facial recognition and pixel values and so forth to students.